Yeah, so looking back at what we were saying here, I guess another idea you can see from this picture is that the partial sums, I shouldn't have started drawing partial sums this far down the chain because it's already interesting. If I take a half, that's also a half less than 1, right? The missing bit is a half big. Well, okay, that's kind of silly, but if I take a half plus a quarter, then the missing bit's a quarter, right? So a half plus a quarter is 3/4, but that's also 1 minus a quarter. If I go 3 steps down this sum, I take a half, a quarter, and an eighth, then the missing bit is an eighth. So then, as you're looking at what you get from the partial sums, the denominator that is nice to use is the last denominator of a fraction in the sum, and the numerator is just 1 less than the denominator. So if you reflect on the picture a little bit, you'll see that as I add up all the way to 1 over whatever, then what I have not covered is again a copy of the last guy. So I'm going to see 1 minus, at this point, 1 minus 1 over 64. And so, when you write that out as a simple fraction, the difference between this and 1 is getting smaller and smaller. So 63 over 64 differs from 1 just by a 64th. And the next guy differs from 1 by 128th. And the next guy differs by 1 by even half as much as that. So these differences are getting tinier and tinier. As you add up the chain, you can see you get as close, if you take as many terms as you want, you can get as close to 1 as you want. And so mathematically we'd say that this represents a limit that converges to a number 1, and what converges from below. That's probably too much detail, but it's a famous problem too. It's called the geometric series.